Assalamualaikum and good day. So I hope you're still energized to continue our lecture. We are going to continue on last lecture. So today we are entering a new title. It's about dimensions. Okay. So first of all, about the basic dimensioning. So for the dimensions of a drawings, you need to have a dimension lines. So this all you're going to go through. Okay, the dimension lines, what is the extension lines, there's leaders, there's also arrowheads, and there's a figures. Okay, you need to have figures for sure, and there's a note, and then there's also a symbols. Okay, if you are referring to these figures, okay, you see my points here. So this is like this is showing you the leader line. Okay, to show what is the size, what is the size of these circles. Okay, so this is the sign of the diameters. So this is local note showing you the diameters or radius. Okay, this is as stated as a note, and then this also shows you the center line. The center lines is also a center of the circles. We call it as a certain center line. And this one where you need to drag your dimension outside of the views. So this one is called the extension line. Okay, this one, if you're following my point here, this is called the dimension, the extension line. Okay, so where we want to know the height, so this is going to be your extension lines. So there's a difference between the extension line and the dimension line. While where you put the dimension, okay, here is your dimension, is 3.5 or 1.7. This is dimension. So beside of the dimension showing you the line, this one is called you the dimension line. So this one is also this is called arrowheads. This is general notes where you shows like the rounds and fillets, radius of 10, 0.10. So this shows you the ISO projection symbols of the drawing. Okay, you are having this top views and your front views, and then there's also showing you what dimension they use for this drawing. So for this drawing they are actually using in inches, even though they don't put like a point, right, like where you have to show this is an inch or this is 2 feet. So this is a value, right, like 8 inch. So they don't need to have this inch symbols. So you just need to mention at the bottom of your drawings the dimension is in inches, or you can either state you are using a matrix units. So the characteristic of the dimensioning, so you need to remember how to draw it. You need to be thin line. Okay, you need to be contrast to the outline of the object. Okay, so it need to be thinner, remember, and the dimension must be clear and concise, and the dimension should not be duplicate from the views, because you're going to have different views, right? It can either be top or front and the side. So make sure it doesn't duplicate or overlap between these dimensions. For the dimension lines are used to determine the extent and the directions of the dimensions. So here showing you the dimension line, as I said before. So the dimension is the value of this is 3.00 is the dimension. So to show you how big is this dimension, where exactly is this dimension, is can be shown by using a dimension line. But if two arrowheads, I mean this showing that when the space is limited, okay, so you can use these symbols where used as a fill-in circles. So you need to note also the dimension line should not be broken for the insertion of the dimensions. And then the line are terminated by uniform arrowheads, okay, showing you this is the types of arrowheads. So these are moving outwards, okay, showing this is the size of the dimension between this line to this line. As for this, when you're having the arrowheads towards inwards, okay, to have inwards, mostly it's going to show you when you're not having enough space, or you are just actually showing mostly is for the diameters, okay. So for the extension lines, so this line is actually the extension line, okay. You need to drag out from the views to show this is okay. For this one is to show you the height of this object, right? So this one is called as your extension line. So you need to have some space in between of the object and the extension line. So how is the placement of the dimension in the drawings? How you need to put it? So here, if you want to show the object, okay, the size of the object, the dimension of the object. So the arrowheads, as I said before, showing you the arrowheads is going outwards, okay, to show the size of in between of this dimension. So mostly if you have not enough space like this, okay, you can show the arrowheads towards inwards, okay. So it shows you actually the size inside of this is actually 3 inches. For example, if you are using the units is in inches, okay. As how to do the dimensioning for obliques, okay, need to be parallel with the parallel with the your plane here. Dimensioning is interstated areas, okay. If there's too many things you need to record in one views, okay, this is how you need to record it. As for the singles style, okay, you need to use, okay, you only need to use a single style of arrowheads for each drawing, okay. Make sure you use the same types. I don't want you to make different types. You have like fill in, there's like just using a sketch and like an arrow. So make sure you have a uniform style of the arrowheads. And then the recommended length and width of the arrowhead should be in the ratio of 3 to 1. So the length is around 3 and the width around 1. As for this, when the dimension lines you draw it, the dimension lines are not broken, so the dimension should be placed above the dimension line. So as you refer to this figure, okay, you have this dimension line, so you don't put it in between of the dimension lines. So means this is showing you the dimension lines, not broken dimension. So your dimension need to put on top of your dimension line, need to be above, okay. And then next, the spacing suitable for most drawing between the parallel dimensions lines is around 8 millimeters, okay. And then try to read this, go through what is this criteria that you need to do for the dimension line, and also you need to avoid crossing the dimension lines, okay. And then by placing the shortest dimension closest to the outline. So here you can see how you do the dimension. At first, the nearest to the outlines of these views, okay, it should showing you the shortest of dimensions, okay. And then when it going to the outwards, okay, farthest from the outline, So you can see that from your dimension also shows the value from the from the shortest to the longest one. Okay, you can't place the longest first and then the shortest is the last. Okay, you need to start with the shortest one nearest to the outline and then getting longer and longer, and until the end the farthest from towards the outline going to be the longest dimension. Okay, for this one, the dimension line should be placed outside the view. Okay, you need to remember, when possible, try to put your dimensions, dimension and dimension lines not in your outline. Okay, not in your object drawing, your object drawing. So shows you, because we want to have this is much more readability. I don't want it to be overcrowded in, and it need to be organized. Okay, so you need to the clarity. You need to be readable. It cannot be overcrowded. It need to be organized. So remember how you shows your dimension. So here is improving your readability of drawing, because the outer side of the outlines, your dimensions is too overcrowded outside. So to show this part, in between of the center line to this center line, so it's much better to put inside. So this one is okay. Okay, it's okay to put inside, because at the outer part where you put all your dimension here, okay, when you put dimension, it's too crowded outside. So it's permissible for you to put it inside, because we want it to be more readability. So this is this is actually an example where you can put your dimension in the drawings, in the object drawings, in your section views or your outlines. Okay, the others, if you try, try to be possible, try to, as you can, to put all your dimensions outside of your views. So for the extension line, also used to indicate the points or line on the drawing to which the dimension applies. So this is to show you which way, or which is the correct way to show the extension line. So it can't be, okay, this one is a incorrect way. It can't be having a same line with your object. Okay, you need to put it outwards from, you need to put out, away from your object. Okay, so this one shows you a correct way. So you need to drag away your extension line to put your dimension. Next, on the extension lines are usually drawn perpendicular to the dimension lines. So however, to improve the clarity, or when there's an overcrowding, extension line may be drawn at an oblique angles, as shown in the figures. This is for the oblique angle, because you want to have like a clarity. It's much easier for you to understand. And then there's the center lines. So here is the center line. Okay, so this is dimension to show you so 1.55 is to show you how far is between the center line of these two circles. Okay, center line is your titik tengah, your center point of your circles. Okay. And then next is when the extension line crosses other extension lines, they should not be broken. I mean, okay, here. So, however, if the extension line cross the arrowheads or the dimension lines close to arrowheads, a break in the extension line is recommended. Okay, if you are having like extension lines, okay, you're showing you this one is which size or what size. You should not have a broken line as shown in these figures. So these figures having a break between the lines because there's an arrowhead occurs to show this the dimension of this the size of each part. Okay, so it's okay to have a break in the extension line if there's a arrowheads as shown in these figures. So how should we place this multiple dimensions? Okay, for sure, as I said, try avoid to put your dimension inside of your outlines. I mean on your drawing object. Okay, try not to put here. You need to drag out your extension line. Go drag the extension line outside. Try to put in upper way for the front views. Okay, for the front views, try to put your dimension on up or your right side. Okay, drag up, and then you can mark it. What is your dimension for each this part? So as I say, you need to have like from the shortest to the longest. Okay, towards outwards, you need to have from shortest to the longest dimension. So try not to avoid this right side drawing. Okay, don't put the dimension like this. So and then how should we place multiple dimensions? So this is other examples of dimension, how to put the dimensions. This is a stagger dimension types, as I said, from the shortest to the longest. So step by step, so it shows it's much better and clearer. You can see. So this one also, this diameters from the smallest to the biggest diameters. So try to avoid also to put your dimension inside of your views, your object. Try to drag all your dimension outside. Okay, as I mentioned again and again. And then again, how should we align the dimension text? Okay, here as you can see, your left side is actually unidirectional. Okay, and then your right side is the aligned one, and it is an old standard where you have this like when you put your dimension is parallel with your dimension line. So by having this current standards, it's much easier because you have like your current views. I mean how you views the numbers is much understand because it align with your aras mata ni, your eyes. So it's much easier to read as this is 1, this is 2, 1, 2. This is an unidirectionals. Second guideline is to if you have double dimensioning of picture is not permitted. Okay, try to avoid to be overlap your dimensions. It's enough to have like A and B. Okay, if you want, you don't need to replicate again. You need to mention A and then there's a B side. So because A plus B will get the C. So you just can start with the only A means from your start line. This is your start. What is this dimension? And then from the start again until the end. So this B. So you will know to get this right. B minus A, you will know get this. So for your these figures is like an overlap data. You try to mention, I know you want to have like to be specific, the dimensions to be specific, so you don't need to put it actually. Enough to have like A and C. Okay, try to avoid this because it's actually related for the tolerance. And then the third guideline, that the dimension should be placed in the view that most clearly describe the features. Okay, you need to know which is the best dimension to put on which views. Okay, either be on top, either be on your front views, or either be on your side views. Which one is the best? Okay, and also try to put like this. Okay, this is on your left side is a correct way contour dimensioning, and your right side is incorrect way. Try to make it like readable. It's much easier. Try to put it's much better to put your dimension in between of the views. Remember from what I said from I think earlier slides. Okay, because okay, if you are referring to these A figures, right? So your front views, the length for the front views and your top views is quite the same. So it's much better to put in between the dimension in between of these views. If you put it on your bottom, it's far away to be relate on. If you want to relate on your top views, okay, try to be more organized and readable. Okay, and also need to know which is the best place for your dimension to put your dimension on which views. Next, on the leaders are used to direct nodes. Okay, so actually most of the leaders are shown in a single straight. Okay, you have a single straight but inclined line. Okay, it cannot be a vertical or horizontal, except for the short horizontal portion extending to the center. Okay, so you just remember, try to put this it showing a leader showing, you need to be shown in a single straight inclined line. Sorry. Okay, the leaders is terminated by an arrowhead or a dot. Okay, so as showing, you have these two different style. So this one is to show you I mean to note you, these actually materials are made from cadmium plate. Okay, so you can show by the dot. Or as for the like an arch or radius or other else for the nodes, okay, for the nodes you can put as a arrowhead as shown in this figure. And then leaders should not cross one another. You cannot be overlap between each other. Try to avoid that. So you need to have like the same line like this showing, not to be overcrowded too. Okay, try to understand and read truly of the slides, the notes, and also the notes. Okay, the notes are used to simplify or complement dimensioning by giving information on a drawing. On a drawing in a condensed and systematic manner. So there's two types of notes. Okay, if you're referring on the general notes where they mention you, I mean they explain, they have explanation. Okay, for example, like this one. If you're please refer this one. Okay, finish all over, rounds and fillet. Okay, R is like radius 0.06. So this one is like as an example of the general notes. So let's go on the local notes. Okay, this is applied to the local requirement only, and then this local notes is mostly going to connected by a leader line. to the point to which node applies. Okay, so this shows you an example of the local nodes. So 4 times to the diameters of 6, 2 times 45 degrees, diameters of 3. Okay, and also if you have if you see this x, okay, x actually shows you symbols that to indicate number of time or places required, because we don't want it to be overcrowded, because sometimes there's too many holes. For example, there's too many holes and it's the same size, so you don't need to keep mentioning which the size of the holes, right? So you can use these symbols x. So there's 4 times of diameters of 6 cm ke or inches ke. Okay, boleh? So let's go on the dual dimensioning. On the dual dimensioning, okay, as it said, okay, as you can read on this slide, so there's a great exchange of drawing taking place between the US and the rest of the world. So it's become advantageous to put these both units in one drawing. So you can have like inches and millimeters in one drawing, but for us, okay, we try to avoid this, okay, because you want it to be more understand. It means when you see, you can easily understand. Okay, it's much better for your understanding too when you see, because sometimes you can be, for me, I'm a very careless person, so I can sometimes can calculate it differently when you're having a different units in one drawing. So it's much better to have one units in one drawing. Okay, next on the angular units. Okay, angles are measured in degrees. Okay, so on the figures is examples of the angles. So you can see when you have degrees, this is the units they use. So always angles, then you need to have put your degrees unit. Okay, that one 180 degrees, 45 to plus minus 0.5 degree. And then the dimension line of an angle is an arch drawn with as apex of the angles as the center point for the arch, wherever practicable. And the position of the dimension varies according to the size of the angles and appears in a horizontal position. So mostly okay, for easily understanding, if you want to show you the angles, try to make your base, your main base is on your horizontal line. So to show you, this one is 10 degrees Celsius, right? So this is your angle here. It's not 10 degrees Celsius, mind me. So it should be degree only. So horizontal is your base and this is your angle. So this is going to be your 10 degree. So this is your horizontal base. And this one is going to be your horizontal base, this one, and this one too. Okay, you can check the figures for your examples. So this is going to I'm going to replicate. I'm going to ulang balik. Okay, I need to ulang balik. You need to remember these basic rules. First, place the dimension between the views. Okay, when possible, try to put a dimension between the views. It's much easier to put there. Second, you need to put a dimension line for the shortest length, width, height, nearest outline of the object. Okay, you need to be nearest to the object, and then you need to draw it from the shortest to the longest length. Then need to be parallel dimension line are placed. And then also remember you need to put dimension at the best views. Which is the best views for you to put your dimension? So remember these three basic rules. And also here shows you one of the symbols. So here shows you the symbols of symmetry. So you need to put the symmetry symbols at the both side, at the end both side of the part. Okay, for example, for this one you need to put your left and your right side. So it shows you you indicate applying the symmetry symbol to the center line. So this is your center line. This one also. So this going to show you step by step how to do the dimensioning in details. Okay, where you need to choose which. Okay, very first you need to choose what is your front view, and then you need to locate the angles, and then choose the dimension. I mean the shortest one, the nearest to be to your outlines. Okay. And then here on the step 2, add dimension line for overalls. So you need to mention overalls of the dimension, height, width, and depth. And then you need to locate if you have a center of the hole using a horizontal and vertical dimension lines. Extend your center lines. For this one, from the center to your this horizontal plane. So you need to mention it, and then outstanding. And lastly, you can put your leader. I mean, if you need to mention it, because this is a circular or circle shape, so you need to note your diameter, or either be your radius. Okay, need to put in the middles. Okay, need to be, you can see right, the arrowheads of the leader need to be centralized between this quarter shape, this line of your circles. Okay, we are entering on the circular features of dimensions. So there's a diameters. Okay, the diameters of a single features or the diameters of numbers of concentric cylindrical features are to be specified. You need to specify all this data, right? So it is recommended if it's shown on the longitudinal views. So this is an example, like there's a 2-view drawing longitudinal. This is your front views, this is your inside views, and then this is 1-view drawing, 2-view drawing. There's also dimensioning. So go through of each type, and if there's a space, it's restricted. So this is the way how you illustrated it. Okay. And then we are entering, before is a diameter, this is radius. So this is going to be a general method of dimensioning of a circular arch is by giving its radius. A radius dimension line pass through or is in line with the radius center terminates with an arrowhead touching the arch. And the size of dimension is preceded by the abbreviation R. Okay, so R means your radius. Simple. R is radius. If you have like circles and slash, that will be your diameter. So this shows you the example and how to put your dimension. Okay, if you have like a curve or an arch, okay, you need to put your arrow, I mean your leader of the leader line with the arrowheads is put on the center of the arch. Then and you can mention your dimension r is 0.1. it also here shows you, okay, you need to see this example actually shows you the pointed of your leader line or the arrowheads is point towards the center of its arch. Okay, so this one also locating the radius center with the common tangent points. So there's tangent points, there's a, okay, go through here, go through all this, try to similarize. You can you can try, you can see the trend how they put the r on the radius of, if you want to know this arch, actually the radius is how much. And then a simple fillet and corner radii may also be dimensioned by a general note such as, okay, we can put a general note if all rounds and fillets unless otherwise specified by r, all radii is r5. Okay, when a radius is dimensioned in a view that does not show a true shape of the radius, true r is added before the radius dimension. Okay, you just put the true first before you mention your radius. Here in the figure shows if you have like a fully rounded ends, okay, so the radius is mentioned but it doesn't shows the dimension. Okay, it's for example 2 times, so means there's 2 2 radius, 2 shapes, right? 2 times r, so it doesn't state the dimension. Sorry. So this one is for the partially rounded ends. So if you have like it's not a full, okay, there's pointed, it's not a fully radius shape, so you need to put your dimension. And where is your center line? So here is your center line, so your radius is around 0.5. And then next, when a hole and radius have the same center, okay, when you have these holes and the radius is same center, okay, it based on this center of the holes, okay, you have a same base. Okay, you understand, right? Is more critical than the location of the radius. Either the radius or the overall length should be shown as a reference dimensions. So you can choose which one is much easier for you to show this as your reference. So from here it shows you the radius of from the center line. This is your r. So also for your radius is actually the same. So you can either choose between these two to show your dimensions. And for this one, so there's a different types of there's the angles, okay, to show you, okay, you have this line. If you want to show the chords, okay, just drag it and show the dimension. This is how you put your dimension for the chords, for the arch. The arch, if you want to know the shape of symbol of arch, so you have this dimension and there's a shape up on top of the dimension value. And then this is to show you the angles. Okay, so this is different way to put symbols for types of chord, or if you want to show the arch, how to show the arch, how to show the angles, and how to show the chord. For the spherical features, okay, spherical features may be dimensions as diameter or radii. Okay, so it also should be, but the dimension actually should be used with the abbreviation of SR or S diameters. Okay, SR is spherical radius SR. So we know actually inside it. Okay, okay, you know, right? This is a symbol of center line. Okay, so by having this, if you have like sphericals, we noted that this is actually a spherical shape with a diameter of 1.25. So spherical shapes of a diameter of 1.0 lah. So this one is going to have a spherical radius of 0.5. So what about the cylindrical holes? Cylindrical holes. So the leader is the most commonly used method for the dimensioning of the holes. So you need to have this dimension, the leader lines. Okay, as I shown in these figures, the dimension is identified as a diameter by placing the diameter symbols in front of the numerical value. Size, quantity, depth may be shown on single line or several lines if preferable. So actually you should understand how to put your dimension for these cylindrical. So you have to have leaders, and then mostly it's going to, if you're cylindrical, must be to have a diameter symbols or signs. Okay, you have leader lines, and you also have this diameter sign. And then continuing on the cylindrical holes. So if you have there's a more of one hole, so you need to use the local notes. Okay, so means you are using the X, means shows that you have four cylindrical holes. For this actually you have like 6 cylindrical holes with a diameter of 0.168, while for this is for diameter of 0.5. So try to go through here all this the example. Try to understand it. If too many leaders would be impaired, okay? And the rigidity of the drawing, letters or symbols should be used to identify the features. So you don't need to replicate again. So there's a common features in the dimensioning. So let's go through it. First, there's a repetitive features. Okay. So we can use as the X symbols. And then there's a chamfers. So chamfers are normally dimensioned by giving their angles and linear lengths. It's when a very small chamfer is permissible to break a sharp corner, it may be dimensioned but not drawn. Okay. There's an internal chamfer, and then chamfer on small holes are usually expressed as a countersinks. So this is an example for this for the 45-degree chamfer holes. Okay, you see there's a line here shows you it's actually a shape of a 45 degree Celsius. It's not 40 Celsius. It's 45 degree. Okay. So if you're having more chamfers, so this is the way how you put the chamfers. So there are singles, the angles, and the horizontals way. Okay. So you can go through all these examples. Okay, try to read more. Try to be familiar with chamfers, and then there's a slope. Okay, there's also a slope if the plane is having a slope or steep of your plane. So you can put symbols. So this is going to be your slope symbols. Okay, so it shows you this actually have a steep area, a slant of a line representing an inclined surface. So you have an inclined surface, or there's a slant shows you on this slant line. It is expressed as a ratio, okay, in the height at right angles to the baseline at specified distance apart. So as showing this, it's based on the 10 degree, okay, here. So it shows you this the ratios of the the angles with the baseline, okay. So this is how you put your slopes. I think this would be our last about the taper, okay. The taper is actually the ratio of the difference in the diameter of the two sections, okay. Later you know which exactly it is. So it shows you the ratio of the difference of the diameters, and the flowing dimensions may be used in suitable combination to define the size and form tapered features. So it can be in diameters, length, weights, include angles, and then there's a tape ratio. So it depends on you which is a suitable combination to define the size and form. So this is your example for the taper symbols. So this is how the shape of the taper symbols, and then this showing you for this one is to show you by a ratio. So this is going to show by an angles. So it all depends. So actually there's much more you can learn actually when you go through when you are going to use the AutoCAD, okay. But this is like a common features of dimensioning. This is a standard one that you need to know before you entering or before you learn. So try to be familiarized of all these dimension. So thank you. We're gonna meet again on the next lecture. Bye.